Now we have myocyte cytoplasm contains a big number of dissolved metabolites. Oh, we have talked about this already. This was in the previous question. Name one of them that turns directly into lactate. And we said that, what do we talk about? We said from pyruvate, it divides into what? Into lactate, or it goes into lactate if there's no oxygen. And it goes to the citric acid cycle if it has oxygen. Good. So I won't waste time on it. So the answer was C. Okay. Now we have emotional stress. Emotional stress causes activation of hormone-sensitive triglyceride lipase in the adipocyte. What secondary mediator? Guys, do you remember secondary mediators? We have primary mediators and we have what? Secondary mediators. We even have tertiary mediators. And we said primary mediators are the hormones that triggers activity in the body, right? Then the secondary mediators are the one that carries the hormone and begins to transform it into a different thing. So here the question now is, which secondary mediator is involved in the hormone-sensitive triglyceride lipase? That means what helps in breaking down adipocyte. And the answer is what? Cyclic AMP. Cyclic AMP, also known as cyclic adenosine monophosphate. Adenosine monophosphate. And actually, this cyclic AMP is involved in a whole lot of metabolism. So some of them include glycogen. So in glycogen, cyclic AMP comes to play. In sugar, like carbohydrate, cyclic AMP comes to place. And then in lipid metabolism, like this case, this is a lipid metabolism or fat metabolism. So we are thinking of what? Cyclic AMP. Cyclic AMP. So here, your answer is A. Good. Now, they said a patient has been diagnosed with acaptonuria. Acaptonuria. Choose the enzyme that is deficient. So the thing is, what then is what? Acaptonuria. Because if you don't know it, obviously it will become difficult to answer. And acaptonuria also means, or another name for it is homogentisuria. 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 And this is a disorder in which the body cannot process the amino acid phenylalanine and then thyroxine. We've talked about this. It cannot metabolize phenylalanine and then thyroxine. Phenylalanine and thyroxine. Like I said, acaptonuria simply means what? Homogentisuria. So its deficiency will be the cause of what? Acaptonuria. Now, if the hormone or if the enzyme was phenylalanine hydroxylase, you could be thinking of PKU. 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 We talked about this in our last lecture. Okay, so here your answer is what? It's homogentisic acid oxidase. So if that enzyme is deficient, then we have what? Acaptonuria. Then if phenylalanine hydroxylase is deficient, then we have this phenylketonuria. That's PKU. PKU. Okay. We talked about it yesterday. That's why I'm not wasting my time on it. A patient was diagnosed with carcinoid of the bowel and was admitted. Analysis shows high production of serotonin. High production of serotonin. Now, it is known that his substance is formed from tryptophan amino acid. Of course, we know that serotonin comes from what? Tryptophan. So now the question is, what is the mechanism of action? What is the mechanism of action? Again, we said tryptophan is synthesized into what? Into serotonin. Into serotonin. And the process is through what? By the addition of hydroxyl group, by addition of an hydroxyl group, and a subsequent removal of a carboxyl group. Again, first you have to add a hydroxyl group, then you remove a carboxyl group from it, or from the tryptophan, and it becomes what? Serotonin. And that process of adding and removing is called decarboxylation. And actually, many hormones are synthesized through decarboxylation and sometimes even transamination. But mostly it is through what? Decarboxylation. Decarboxylation. So here we are thinking of E. Oh. Okay. We have a genetic specialist analyzed the genealogy of a family and found that both males and females may have the illness. This one, they said both. In the previous one, they said only the males. If it is only the males, then you are thinking of what? Y-linked. But over here, they are saying what? Both males and females. Not across all the generations. That means it is not occurring in every generation. So if it is not occurring in every generation, then you could be thinking of what? A recessive gene. You could be thinking of a recessive gene. You could be thinking of a recessive gene. And they are saying that healthy parents may have ill children. Healthy parents may have ill children. What type of inheritance is it? So here we are thinking of autosomal recessive. Autosomal recessive. Now, in Y-linked, like I said, it will mostly be found in what? In males, right? Now, in autosomal dominant, it means all generations might have it because the allele is dominant. That means it doesn't care whether there's another one or not. It has to dominate. So in autosomal dominant, it means to occur in all the generations. But over here, they say it did not occur in all the generations. Now, in X-linked, if it is X-linked dominant, that means it can be found in what? In fact, in everybody. But males, to be specific, males, and then, yeah, it could be found in what? In males. Sorry, in females, sorry. X-linked. It could be found in females, and it could actually be found in what? In males as well. But this is not X-linked dominant. If it is X-linked dominant, that would mean that the parent could, or the mother could be ill. The mother could be ill. That is if it was to be X-linked dominant, because the mother contains what? X. But over here, the mother is healthy. That means that it could be what? A recessive. It could be a recessive. And perhaps it has nothing to do with the X-link. So here, we are thinking more of what? Autosomal recessive. Autosomal recessive. So E will be our likely what? Answer. E will be our likely what? Answer. It's unfortunate that I'm trying to do some tutorials on, some few topics, but I doubt you people might benefit from it now. Because I want to be later when I'm done with all of these things. I'll have time to treat some topics that are confusing for people so that they can be able to understand it better on my YouTube channel. Okay, that was just by the way. Now we have analysis of amniotic fluid. You know, amniotic fluid is what covers the baby, or that is the water in which the baby swims inside. Now they said they obtain what? Obtain from what? Amniocentesis, that is puncture of the amniotic sac, revealed cells. Revealed cells, what are I saying? What they're trying to say that the cell contains what? Chromatin, contains sex chromatin, that's a bar body. What can it be evidence of? So there's a bar body. Now, Usually we have what we call XX, okay? Then we have what? XY. Okay. Now, X is an active nuclei. Okay. Now, if there's a presence of an inactive nuclei, which is the bar body, so bar body simply means what? An inactive X chromosome. An inactive X chromosome. Now, in females, they have one active and then one inactive. That is it. Now, in males, they do not have any inactive. They do not have a bar body. They don't have a bar body. So this one, you could be thinking of what? The development of a female fetus, female child, because this is what? XX. Again, but if you see 2X, sorry, XXX, that means two bar bodies. It means you are thinking of what? Trisomy X. You are thinking of trisomy X because you're not supposed to find what? A bar body in males. All right, so here your answer is what? Is A. Guys, look at this again. They said there is vitamin B1 deficiency. Vitamin B1 deficiency. And we've talked about vitamin B1 like 1,000 times. Vitamin B1 is thymine. Am I right? It is thymine. And I said, this thymine pyrophosphate is a coenzyme. For what? For pyruvate. It's a coenzyme for what? For pyruvate. It's a coenzyme for pyruvate dehydrogenase or pyruvate. So here, without wasting my time, your answer is what? It's thymine pyrophosphate. Thymine pyrophosphate. So if you understand it, you don't need to worry. A child's blood presents high content of galactose. Guys, we talked about this. Galactose. We talked about this in our first lecture. Now, glucose concentration is low, of course. Now, there's what? Cataract. There's mental deficiency. There's adipose degeneration of the liver. What disease is it? What disease is it? So first of all, you are thinking of what? A deficiency of which enzyme? Galactose 1 phosphate uridyl transferase. Galactose 1 phosphate uridyl transferase. And this simply means galactosemia. So here, your answer is what? Is A. Now, in that question, they said a patient is having galactosemia. Which enzyme is deficient? Which enzyme is deficient? So if they ask you which enzyme, you are thinking of what? Galactose 1 phosphate uridyl transferase. Galactose 1 phosphate uridyl transferase. So here, your answer is A. According to the clinical indication, a patient was administered what? Paradoxal phosphate. And paradoxal phosphate simply means what? Vitamin B6. Vitamin B6. What processes is this medication intended to correct? Like I said, so basically it has to do with vitamin B6. Vitamin B6. And this involves what? Transamination, decarboxylation, and deamination what? Reaction. And usually it is involved in what? In the synthesis and the catabolism of neurotransmitters. Do you remember a question of isoniazide? We said people who have tuberculosis, we give them what? Isoniazide. And these people are likely to develop what? Neuritis or polyneuritis. That is a problem with the what? With the neurons or even in the eye. Okay. So because of that, we normally add what we call B6 vitamin to it or vitamin B6 to it. And the reaction or the process or the mechanism of action is what? Transamination, decarboxylation, and what? And amination. So, and deamination. So this is the, and of course, it's of what? Amino acid. So here we are thinking of what? Of D. We are thinking of D. We are thinking of D. We are thinking of D. All right. Great. Now, they say a woman is suffering from Cushing's syndrome. Guys, do you remember Cushing's syndrome? Where there's high amount of what? Cortisol. And there's a moon-like face, isn't it? Great. Now, they say it's suffering from what? Steroid diabetes. When we say steroid diabetes, that means there's diabetes and also there's increase of what? Of cortisol what? Level. There's increase of what? Cortisol level. Now, they say there's what? There's hyperglycemia and hypochloremia. Which of the following undermentioned processes is the first to be activated? Is the first to be activated? Great. Is the first to be activated. So definitely, since there's a steroid, cortisol level. What does the function of cortisol do? What they do is that they increase what? Your BP. They increase what? Gluconeogenesis. That is one aspect of Cushing syndrome. They increase what? Gluconeogenesis. Gluconeogenesis. That's what cortisol do. Cortisol increases gluconeogenesis. So over here, we're definitely thinking of what? Gluconeogenesis and liposis. And gluconeogenesis simply means what? You are producing glucose from non-carbohydrate what? Substances. Glucose from non-carbohydrate substances. So here your answer is D. Now, a patient has been ill with bronchial asthma for many years and died from asthmatic fit. Now, examination reveal what? The lumen of the bronchioles and the small bronchioles contain a lot of mucus with some eosinophils. There is sclerosis of the alveolar sputums and dilatation of the alveolar lumen. What is the mechanism of hypersensitivity reaction? Guys, what type of hypersensitivities is bronchial asthma? We have type 1, type 2, type 3, type 4. What type is it? Of course, this is type 1. This is type 1, also known as immediate hypersensitivity, also known as ranging reaction or ranging hypersensitivity. So all of these things mean the same. So again, you are thinking of type 1, you are thinking of immediate or ranging. So here you are thinking of what? Of D as your answer. D as your answer. All right. Desulfiram is widely used in a medical practice to prevent alcoholism. Good. Now, if you have worked in the ward, you will know what this is all about, or the emergency department, you know what desulfiram is all about. Now, it inhibits aldehyde dehydrogenase. Now, increased level of what metabolite causes aversion to alcohol? Causes aversion to alcohol. So, first of all, you must know that alcohol is normally converted to acetaldehyde. Acetaldehyde. So, when you take in alcohol, you are actually storing what? Acetaldehyde. So, what it means is that if you want to stop alcoholism, or you want to stop the effect of the alcoholism or the alcohol, you have to inhibit 8 enzymes. You have to what? Inhibit 8 enzymes. And that's why we give what? Desulfiram drug. That's why we give desulfiram. So here you are definitely thinking of what? Acetaldehyde. 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 Okay. Now, I just saw ethanol. Don't forget, ethanol and methanol, they are all different things. Now, if somebody is intoxicated with methanol, we give what? Ethanol, right? So please take note of it. It is different from someone being what? Alcoholic. Great. Guys, look at this again. A patient, 1-year-old child with symptoms of muscle involvement. Look at this. Examination revealed what? Carnitine deficiency. We've spoken about this. What is the mechanism of action? Of course, transporting of what? Fatty acid from the cytosol to the mitochondria for burning. And I said this substance is what? Is deficient. That means that this patient or this boy will become fat eventually because the fat will not be burned. The fatty acid will not be sent for burning. So here is A. Why I said Krok, you shouldn't, and the next will not be suffering for Krok. They are easy. Questions are very, very easy. But that is if you understand it. So please, take note of all these points. We are mentioning them. Now, the patient with complaints of permanent test applied to the doctor. Guys, look, there's hyperglycemia and polyuria. What they're talking about? They're talking about diabetes, right? Now, there's increased level of what? Steroids. You're talking of what? Of course, steroid diabetes. There's hyperglycemia, polyuria, which is the same as what? Diabetes. And there's increase of what? Steroid hormones or steroid substances. That's 17 ketosteroids. So definitely you are thinking of what? Steroid diabetes. Steroid diabetes. An index of a pH of the blood changed and became 7.3 in the patient with diabetes mellitus, detecting of the component of what BAHA system. Now, it is worth knowing that bicarbonate BAHA is the primary buffering system of the body. Please, the primary system or buffer system of the body is what? Is bicarbonate. Is the bicarbonate. Bicarbonate. So please take note of this. Take note of this. Bicarbonate. Bicarbonate. Good. And that is why when a patient is excreting all this bicarb, that is acid, excreting it out, what happens? The patient becomes to find what? To feel what we call metabolic or excretory what? Acidosis. Excretory what? Acidosis. Excretory what? Acidosis. Okay. Now, as a result, guys, we've done this already, but look at this in a different way. In a different way. They said as a result of post-translative modifications, some proteins taking part in the blood coagulation, particularly prothrombin, became capable of calcium binding. Which vitamin? So they just brought all these prothrombin just to confuse you. Please, your answer is what? Vitamin K. Vitamin K. I've told you, vitamin K. And the process is what? It's a carboxylation of what? Of glutamic what? Acid. Carboxylation of what? Glutamic what? Acid. So please, this is what? Vitamin K. Now, objective examination of the patient revealed slender figure, big skull, highly developed frontal region of the face, and short extremities. What is this constitutional type typical of? Well, I try to look for the different types, but usually this is usually with respect to what? With respiration. This is with respect to what? Respiration. Now, if, for instance, the person is kind of muscular in shape and things like that, you could be thinking of what? Of muscular. Now, if the person is perhaps having all the kind of what? Obesity kind of a lifestyle, you could be thinking of what? Digestive, right? You could be thinking of what? Digestive. Now, for cerebral, I don't really know how they present. And of mix means mix. That means you see every part of it there. So the person is muscular, the person is what? Having respiratory and what? Digestive, all of them. mix. But this one, basically, we are talking about what? The respiratory. So please take note of this particular question. Take note, because it will come as respiratory. I'm not seeing other version of this question yet. But of course, maybe the new questions can come. Okay, so here, your answer is what? Respiratory. Good. Now, a 38-year-old died during what? Intractable attack of bronchial asthma. Guys, bronchial asthma. Everything here is about bronchial asthma. But the question is, what type of hypersensitivity are they talking about? Because the question is, what pathogenesis of the bronchial asthma, of the bronchial changes is it? So over here, they're looking for what? The type of hypersensitivity. And I said, this is what? Type 1. This is what? Immediate. This is what? Ranging. Another name is what? Atopic or atopy. Atopic or atopy. Atopic or atopy. So they all mean what? The same thing. Ranging, atopic, type 1, or immediate hypersensitivity. All of these things means bronchial asthma. Yeah. Excuse me. Where we are now? And also. Oh, Matty. Let me watch it. You gave me. There you go. Come rest and you go. I have all of them. It's Minya. What's it? Yeah, for the other bag. But you win here events, but Manfamba, win here get the sums. No go if Manfamba. Kakanya. Mati. Dabe. Wouldn't that coffee be about you because Meko gonna a chanopa? Meko gonna. Oh, because you have events in scan. I'm gonna Dr. Uzu Chemi. Ultrasound. Doesn't be a good auntie. Oh, 3 days. Oh, we didn't know. But we get them in the bar. See. Yeah, that is yeah. My study, I chew. Oh, my study. Oh, let me come into the people was me a call. Maybe a little on our original fee because Obefi no more yama. All right. Magic. Okay. Sure. All right. Sorry, doctors. So we have what? Diabetes mellitus causes ketosis as a result of activated oxidation of what? Fatty acid, of course. So this is what? DKA in a way. What disorder of acid-base equilibrium may be caused by excessive accumulation of ketone bodies. Ketone bodies produce a lot of what? Acid in the what? In the body. It produces a lot of what? Acid. So as a result, we call it what? Metabolic acidosis. We call it metabolic acidosis. And we said acidosis means what? There's increase of what? There is increase of hydrogen ion concentration. And then in alkalosis, there's what? Decrease of hydrogen ion what? Concentration. Then when we talk about excretory acidosis, we're actually referring to what? Diarrhea. Then we talk about vomiting. It gives what? Alkalosis, because you are vomiting what? Acid out. You are vomiting acid out. So to give you what? Alkaline solution. So here we're talking about what? D. Metabolic acid, because ketones produces what? Acid in the body. So here your answer is D. Okay, a woman with blood group O has born a child with AB blood group. AB blood group. So it could be that this child took this AB maybe from the father. Now, this woman's husband has A blood group. A. So where does this baby got the B from? Anyway, so what genetic interaction explains this phenomenon? What genetic interaction explains this phenomenon? Explains this phenomenon. And over here, we are thinking of what? Actually, the answer is not there. Okay. The answer is not here. Because although they are saying this answer is recessive epistasis, for me, there's no way somebody with blood group O and the father is A can give birth to a blood group AB. It can never happen. It can never happen. Look at this. So we have O. So O means OO. Okay. Now, the man with with A means he has what? A and then what? O. Usually the O is recessive. O are recessive. So the O will not show, but the A will present. What it means is that the child can either be what? Be A. The child can either be this and this. Okay. Then this and that. And then O. Basically, this is what the child can be. Either O or A. As simple as that. So the answer is not in this what? Question. However, according to Krok, this is what? Recessive epistasis. Recessive epistasis. Recessive epistasis. So we'll take it as it is. But it's not possible. It's not possible. All right. Now we have depressions and emotional insanities result from a deficit of noradrenaline, serotonin, and biogenic amines in the brain. Now, their concentration in the synapses can be increased by means of antidepressants that inhibit the following enzymes. So first of all, you must know that dopamine, serotonin, noradrenaline, adrenaline, and histamines are all monoamine neurotransmitters. They are all monoamine neurotransmitters. Monoamine neurotransmitters. Therefore, if you give a monoamine oxidase inhibitor, it can inhibit these hormones. So over here, the enzyme that we should go is what? That can inhibit the following enzyme is what? Is the monoamide oxidase what? Inhibitors. Monoamide oxidase inhibitors. So that one will be the most appropriate answer, but it should have been what? Monoamide inhibitors. So here, your answer is E. Okay, guys, look at this question. Very, very common. A 3-year-old child with symptoms of stomatitis, gingivitis, dermatitis of the skin, of the open skin areas was delivered to hospital. Examination revealed inherited disturbance of a neutral amino acid transporting in the bowel. What vitamin is it? That's a question. We made mention of dermatitis like, let me say 2 million times, where we have a vitamin PP, Pellagra. Okay, so, and we said Pellagra or vitamin PP is the same as what? Niacin or vitamin B3. Niacin. So here we are thinking of what? Vitamin B3 or niacin or nicotinic acid or nicotinamide or Pellagra or PP. You see all these things, you already know them. So here your answer is E. Now, during hypersensitivity test, a patient got subcutaneous injection of antigen, which causes reddening of the skin, edema, pain as a result of histamine action. Histamine action. Histamine action. And I made mention that many biogenic amides become active when they undergo through a process called what? Decarboxylation. When they undergo through a process called what? Decarboxylation. So over here, you are thinking of what? Decarboxylation. Decarboxylation. But the question now is what? This biogenic amide is generated as a result of transformation of the following histidine amino acid. So this would be what? Histidine decarboxylase. That is the enzyme. But the process is called what? Decarboxylation. So here, your answer is B. Your answer is B. So always apply. Always apply. Apply. I love this question. Look at this. A patient was suspected of having what? Progressing muscular dystrophy. We talked about this like a million times. I think so. Now, muscular dystrophy means what? Muscle degeneration. And we said if you want to confirm, what do you look out for? You look out for what? Creatine. 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 So here we are thinking of what? Creatine or creatinine kinase or CPK. CPK or CK. They all mean the same thing. As over here, they spell it as K, but it's actually C, creatine. Creatine. So again, if you have not watched our video, please do well to get the video and watch it because you have missed a lot. And please try and revise because everything is just repetition, but in a different way. Good. I love this question too because you know it. Look at it. A patient is complaining about dizziness, memory impairment, periodical convulsion. That means the brain is what? Is hyper. It's hyper. So you need to give what? A substance that what will counteract it. An inhibitory what? Substance. An inhibitory what? Substance. And we said to activate them is what? Decarbox. You see the photo in there? Decarboxylation of glutamic what? Acid. So what will it do? It will activate the gamma. It will activate gamma. Because gamma will serve as an inhibitory what? Neurotransmitter to block the convulsion that is taking place. And as a result, patients will have memory improvement, and every other thing. Okay. Guys, me and I'm tired of this carnitine guy. Look at it again. He was recommended to take preparation that contains carnitine. What does it do? Please. If anyone of you get this question wrong, I'll come to the exams room and lash you in the exams room. Okay. Guys, look at this question. A doctor examined a child and revealed symptoms of rickets. Please, that is rickets. Ricket. And ricket is as a result of the deficiency of course, vitamin D. Vitamin D. And vitamin D is the same as 125 dihydroxycafis. Masa, please, this is what D3. This is D3. People shouldn't confuse me. So this is what? Vitamin D, please. Vitamin D. So just go for vitamin D and be free. Rickets is same as what? Ricket is same as what? Ricket. So please don't get yourself what? Confused. So either you see vitamin D3 or you see calciferol or you see what? Yeah. This 125 hydroxy, blah, 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 blah. All right. Guys, I love this question because we did it. Laboratory examination of a child revealed an increased concentration of, do you remember leucine, valine, isoleucine, and their keto derivatives in the blood and urine. And look at this. over here, they've given you the name of the disease, maple syrup. You remember we said the disease is called what? Maple syrup what? Disease. Maple syrup what? Disease. And what is the enzyme that is deficient? I made mention of it like 1,000 times. So this is what? Branched chain alpha keto acid dehydrogenase complex. I talked about this. Branched chain alpha keto acid dehydrogenase. Okay, so over here, you are thinking of what? Dehydrogenase of branched amino acid is the same thing. Is the same thing. Is the same thing. So if you see that these leucine, valine, isoleucine are not being utilized and are concentrated in the blood, please, you are thinking of maple syrup disease. And in the previous question, the question was, what is the disease? What is the disease? You see? But over here, they've given you the disease and they're asking you, what is the enzyme? And I remember I made mention of it. So please write it down. All right. Oh, see this question again. Convulsion. Convulsion. Convulsion again. Convulsion again. So, of course, GABA. Please. It is what? GABA. GABA. And look at it. Look at this. Oh. A 9-year-old infant is fed with artificial formulas with unbalanced vitamin B6 concentration. Now, the infant presents with pellagra. Pellagra is what? That means B3 deficiency has come in. Pellagra is what? Dermatitis. There's convulsion and anemia. Now, convulsion development might be caused by the disturbed formation of course, it means what? GABA. So if GABA is not there, what it means is that there would be what? Hyper exaggeration in the brain or too much firing by the neuronal cells. Therefore, it will lead to what? Convulsion. Convulsion. So it means that gamma was reduced in the brain. So the answer is what? GABA. GABA. Good. Now it was found out that some compounds, for instance, fungi toxins and some antibiotics can inhibit the activity of RNA polymerase. Guys, do you remember RNA polymerase? Of course. We talk about polymerase 1, 2, and 3. We talk about polymerase 1, 2, and 3. And we said polymerase 1 do what? Transcribes what? RNA. That is ribosomal what? RNA. Ribosomal RNA. And we said type 2 or RNA polymerase 2 will do what? Will transcribe what? Messenger RNA. And type 3, we have what? Transfer RNA or tRNA. But over here, the question is not about which type of RNA polymerase. The question now is what process will be disturbed in a cell in case of inhibition of this enzyme. And again, we made mention that a polymerase is an enzyme that synthesizes long chains of polymers or nucleic what? Acid. It synthesizes what? Long chain of what? Polymers or what? Nucleic what? Acid. Therefore, if you are inhibiting RNA polymerase, what you're actually inhibiting is what? Is transcription. What you are actually inhibiting is what? Is transcription. Again, I said it transcribes. When I say it transcribes, it means what? Transcription. You see how sweet medicine is. And biochem, to be specific, is. Polymerase 1 will transcribe this. Polymerase 2 will transcribe that. Polymerase 3 will transcribe this. So you're talking about transcription. Transcription. So here, your answer is A, transcription. Transcription.